Tina slowly. We be working all day long, the push us bunny. We ain't playing no games, Sabatavi, Gani.
Good day, 311. I hope you are good. Today we'll be busy with exponential equations. We'll be solving exponential equations. Maybe you're asking yourself, what is exponential equation? So an exponential equation is an equation in which the variable is the exponent. So I do believe that you learned how to solve basic exponential equations, make all the bases the same, usually by rewriting them in terms of prime numbers, use the laws of exponents to simplify both sides to a single power, and equate the exponents to solve resulting the equation. So in grade 10, so consider this example that we have 3 to the power x equals to 9. So I need to write 9 to the base 3 so that I can equate the exponents. So we know that 9 is 3 to the power 2. If we write this one in what? In prime base. Remember your exponents. So in prime base. So now the bases are the same because this is a single power and also a single power. Now the bases are the same. Now we can conclude that our x is equals to 2. So in this step, once your bases are the same, you equate the exponents. How do you find your prime base? Guys, I already showed you how to find the prime base. So you have 9, then you just press equal sign, then you press again shift, then you press fact. Can you see that it's 3 to the power what? 2. So also take a note that, guys, we said this is your base. Also take a note that, guys, b to the power x, let's consider this is your base, must always be greater or bigger than 0 for all real values. Values so of x, where this b is bigger than 0, or which is your base in this case, guys. So for example, this base will never be equals to 1, because if I say 1 to the power 2, this is the same as 1, it does not change. So let's say consider, for example, because I said this, the base here, b to the power x, must always be bigger than 0, which means whatever prime number that is raised to an exponent must always be bigger than 0 for all real values of x if you are solving for x. But if you are solving for p, for all real values of p, and your base must be bigger than 0. In other words, it must start with 2, 3, or maybe 1 over 2 here, as long as it is bigger than 0, because we know that 0.5 is bigger than 0. So if we consider, for example, so that you can see this, let's say if we're using this one, let's say we have x here is equals to minus 2, and let's use this equation again. Let's take this one. We have 3 to the power x. So 3 to the power x, in place of x, can you substitute this? So this is written in negative form. Write it in positive form. It's going to be 1 over 9. So 1 over 9, if you can press your calculator, that it is greater than 0. So even if we can have, let's say for example again, x is equals to 0. If you say 3 to the power x again, 3 to the power x, and then you put your 0, can you see that you get 1? Because we said anything raised to the power 0 is 1, and 1 is bigger than 0. So even if you can say, for example, x is equals to negative 1, this is 3 to x is equal to 3 into negative 1, which is the same as 1 over 3, which is also bigger than what? 0, the value. So this means This means that the expression of 3 to the power x, there is no real value of x for which 3 to the power x is lesser than 0. There's no value. So this means that whenever we have 3 to the power x equals to a negative 2, let's say this is no solution, because we can see that this expression is always greater than 0 for all real values. So that's why we said that, guys. So whenever you are solving for x, when you have two solutions and other one is negative, just know that there will be no solution if you have the expression equals to a negative number. Okay, let's go back to grade 10 and try to attempt few questions that you did in grade 10 here. Remember, grade 11, you can pause the video and try to attempt these questions on your own. So we're going to do number A, which is 3 to the power x equals to 1 over 27. So here I have 3 to the power x equals to 1 over 27. Okay, so I have 3 to the power x is equals to 1. So let's find the prime base of 27, because the aim here is to make the bases to be the same. So the prime base of 27 is 3 to the power 3. Now the bases are not the same. Let's write this one in negative form. So it's going to be 3 to the power x equals to 3 minus 3. So now, guys, I hope you agree with me that the bases now are the same, so we can equate the exponent. Now we can conclude that your x is equal to negative 3. So even if you can take negative 3 and substitute here on your left hand side, you must get this one. So even if we can say 3 to the power negative 3, you'll see that it's 1 over 27, which means your answer is correct. So I'm going to cut here, guys, so that we can do number B together again. So we have 3 times 5 equals to 0.6. So here, guys, can you see now the bases are not the same? We must write the decimal as a fraction in order to see what's happening. So I have 3 to 5. Here I cannot even perform the laws of exponents because the bases are not the same. Law number 1 will not work here. So 0.6 is the same as 6 over 10. Then now the bases still are not the same, guys. Then I divide both sides by what? By 3. Then I divide both sides by what? By 3. So this cancel out because I want to find, I want to make the single power here. So I have 5 to the power x. So if you divide here, guys, it's the same as 6 over 10 times, because we have 1 here. Then you will do a reciprocal here, which is 1 over 3. So 6 times 1 is 6. 10 times 3 is 30. So 6 goes to 6 1 time. And 6 goes to 30 5 times. So it's going to be 1 over 5. So I have to write this in negative form. So it's going to be 5 to the power x equals to 5 to negative 1. So now I can conclude that my x is equals to negative 1. Yes, that's good. You can test your answer that you have 3 times 5 to the power x. In place of x, then you put the solution that you have, which is negative 1. If you press SD, can you see that you still get 0.6, which means your answer is correct. Okay, let's take number C, guys. So if we go to number C, I hope that you notice something here. So number C, I have 16 to the power x times 2 to x plus 1 equals to 5 fifth root 4. Okay, you can pause the video and try to attempt these questions on your own, guys. So I need to find the prime base of 16 because we see that 2 is already a prime number. So it's simple, guys. I'm going to change 16 to be 2 to the power 4. Then I close the brackets. Then remember, 16 was raised by 6 by x, so I put x outside, so then I times by 2, then x plus 1 equals to. So this one, guys, I'm going to apply a root definition. Root definition says that if I have n to the power a to the m, this one changes to become a if I write it in powers of a rational exponent. So this one becomes my numerator, and this one becomes your denominator. So it's going to be a to the power m over n. So here, guys, the power that you have here, it's 1. So this thing is going to be the same as 4 to the power, yes, 1 over 5. Yes, that's good. So now, which law I can apply here? Yes, it's law number 3. So I'm going to have 2, then I say 4 times x, that's 4x, times 2 to the power x plus 1. Then let's change this one and write it to a prime base. So it's going to open the brackets and have 2 to the power 2. Then remember your power was 1 over 5. Okay. Now, guys, remember, you are not allowed to say 2 to the power 4x times 2 to the power x plus 1. Then you say 2 times 2. Then you say it's 4. Then you add the exponent. You are not allowed. So just know that if you multiply the bases, you are going to make your teacher sad and try at the same time. You don't want that, guys. So now, can you see now the bases are the same? Which law you need to apply? Yes, it's law number 1. So you take one base and add the exponents. So we are going to have here 4x plus x plus 1. Okay? Now, on my right side, which law I can apply? Yes, it's law number 3. So I have 2, then I say 2 times 1 over 5, then we get 2 over 5. Okay. So now if we see 4x plus x will give us 5x plus 1 equals to 2 over 5. Yes, guys, we meet our target here because the aim was to get the left side to have a single power and the right side to have a single power, but the same basis. Now the bases are the same. Now we equated the exponent. So therefore 5x plus 1 must be equals to 2 over 5. Then you transpose 1 to that side. So you have 5x is equals to 2 over 5. Then if you transpose positive 1 to that side, the sign is going to change. So now you have 5x here. So 2 over 5 minus 1. And then you get what? You will get a negative 3 over 5. Then simple, you divide by 5 both sides. Whatever you do on your left side, you must also do it on your right side. So this 5 will cancel out. So therefore, your x is going to be negative 3 over 25. That's your final answer. Okay, right. Let's move to number D and see what do we have on number D. Remember, guys, you can pause the video and try to attempt these questions on your own. Number D, we're given 6 to the power x. Okay, let me copy this question down. This is D. We have 6 to the power x plus 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 6 to the power x equals to 6 to the power 6x. Yeah. So now, guys, this thing is simple. This 6 to the power x, they are not multiplying. We are adding the exponent, the bases. So now the bases here are the same. It's more like we are having x plus x plus x plus x plus x plus x. So your answer was going to be 6x. So now you have to consider that you have the coefficient here, which is 1 here and 1 here, and the coefficient which is 1 here and 1 here and 1 here and 1 here. So you just say 1 plus 1 is 2 plus 2. 1 plus 1 is 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 1, 6. Which means here we have 6 to the power 6 times 6 to the power x. Ne? Now, equals to what? To 6 to the power 6x. We're just adding this, guys. Is the same as if I have y plus y plus y plus y. So you have 1 here, 1 here. These are like terms. You just have y plus y is 2 plus y 3 plus y, which means we have 4y. Even if you were having y squared plus y squared plus y squared, you are going to have 4y squared. This is the same. So the aim here, guys, the bases here are the what? Are the same. So I have to take one base and add the what? The exponent. So the power here was 1. So equals to 6 to the power 6x. Now the bases are the what? Are the same. So I will drop the what? The exponent, or equate the exponent. Understand? So now we have to collect the like term. So I have x plus 1 equals to 6x. Remember, we were having this exponent, which is 6x, and I have this one. So if I transpose x to that side, I will be left with 1 is equal to 6x minus x. So we drop 1 again. So 6x minus x, what do we get? It's 5x to the 11. Then we divide both sides by what? By 5. So that we can isolate x. Then this one cancel out this one. So therefore your solution, it's 1 over 5. That's it. Yeah? You have to write your answer in positive form. So let's do the last question. Right. Number E, we have 0,375 to the power x. Here we have 9 over 64. Remember, guys, we said that here on the first video, whenever I see the fraction, I must write it in. Whenever I see the decimal, I must write it in fraction. So we know that, guys, 0,375 will give us what? 3 over 8. So we have here 3 over 8 all to the power x. Now I have this one. Already 3 is already a prime number, but 8 is not a prime number. So I have to think here. 9, guys, is a perfect square, and 16 and 64 is a perfect square. If I go straight to 9 squared, remember we always have 2 here, which gives me 3. If I go to square root of 64, which gives me 8. These numbers are these number that I see here. So I'm going to open brackets here and put 3 over 8. Then I raise by 2. Remember your laws of exponents, guys, from the first video. So this thing tells me that this power multiply every exponent here inside. 3 to the power 2 is 9. 8 to the power 2 is 64. So now the bases of the what are the same. Now we can conclude that x is equals to 2. So that's your solution. So guys, I hope you enjoyed the lesson. This was the last question for revision in grade revision in what you did in grade 10. So on the next video, we are going to do the questions that you are going to deal with in grade 11, but you need all the basics. So that's why we started doing the revision for what you learned in grade 10. So see you on the next video. Thank you for watching. Tell us how do you feel about our class, our lessons. Please don't forget to subscribe if you didn't subscribe. Like the video and hit that button or the bell button or notification button, so that you will get notification if we have something new in our channel. Thank you for watching. See you on the next video.